Okay, the last section for this chapter before the test is solving or factoring special cases, right? So now the first special case is what we call a difference of two squares, okay? So it's a difference of two squares. Now this is when we have some number squared minus some number squared, right? So how would we do this? Well, the first thing we're going to do is take something like 3x plus 5 and multiply it by 3x minus 5 to explain this. When I go ahead and I look, I have the same binomials, but one's linked by addition and one's linked by subtraction. When I go ahead and FOIL this out, I had 9x squared minus 15x plus 15x and minus 25. What you notice here is when you go to combine like terms in the middle, these middle terms cancel out, and I'm left with 9x squared minus 25. Now this is what we call a difference of two squares because I have two terms linked by subtraction, and each of these terms are perfect squares, right? Meaning I can take the square root of these evenly. The square root of 9x squared, the square root of 9 is 3, the square root of x squared is x. The square root of 25 is 5. So to factor this, right, 9x squared minus 25, we would come back, we would add the square roots, and we would subtract the square roots. So this would become the square root of x squared plus the square root of y squared times the square root of x squared minus the square root of y squared. All right, which ends up being x plus y times x minus y. Okay, so let's look at the first couple of examples they have here, right? Anytime I see two terms linked by subtraction, I look to see if I can take the square root. The square root of x squared is x. The square root of 121 is 11, meaning what to the second power? Since these are both two perfect squares linked by subtraction, all I do is I add the perfect squares and I subtract them. And this is factored, meaning if I multiply this out, I would get what I started with. So the next one, I'm going to take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. Then the square root of 25 is 5. So I have two perfect squares linked by subtraction. Therefore, this would factor out to be add the perfect squares, then subtract them, and you are done. The last one here, see if you can take the square root. The square root of 100 is 10. The square root of x squared is x. The square root of 36 is 6. The square root of y squared is y. I have two perfect squares, but right? What did we forget to do? Anytime you do this, you have to factor out the GCF. So what's the common factor between 100 and 36? Right? That would be 4. So I'm going to do 4 times, divide both of these by 4, and I'm left with 25x squared minus 9y squared. So let me write this a little neater. Okay, so we have 4 times, divide this by 4, you get 25x squared. Divide this by 4, you get minus 9y squared. Now I look, I can take the square root of each of these. So the square root of 25x squared is 5x. The square root of 9y squared is 3y. So 4 times 5x plus 3y times 5x minus 3y. So remember, anytime we factor, we always have to start with the greatest common factor. Alright, so one last thing. Even if I have two perfect squares, right? Such as 9x squared plus 16. Here's the thing. If these two perfect squares are linked by addition, this is not factorable. Okay? It has to be two perfect squares linked by subtraction. Alright. Let's do this. Let's look at another one. Now, what happens is sometimes I can square a binomial. And if I square a binomial such as, x plus 6 squared, I would write this out as x plus 6 times x plus 6. Now when I multiply these, that would give me x squared plus 6x plus 6x plus 36. When I combine these middle terms now, they double. So I would get plus 12x plus 36. What this is called a perfect square trinomial. So when I square a quadratic, this is what happens, right? If I take the square root of this first term, I get x. If I take the square root of the last term, I get 6. Now, if I can multiply these together, I get 6x. And if I double it, I get the middle term, 12x. Anytime that happens, what you end up getting is the square root of the first term plus or minus the square root of the second term. Alright, let's take a look at this. Okay, so if I have x squared plus 14x plus 49, if I take the square root of x squared, I get x. If I take the square root of 49, I get 7. If I multiply those and double it, do I get 14x? Is 2 times 7x going to give you 14x? Yes. Therefore, this would just be x plus 7 all squared. Now, if you remember back from the last chapter, what multiplies to give you 49 and adds up to give you 14, right? That would be 7 and 7. So you would get x plus 7 times x plus 7, which could be written as x plus 7 all squared. But when you get these perfect square trinomials that end up being a lot bigger, then you have to be a little more careful, because if you use this method, it's more difficult because of the bigger numbers. Okay, the next one, if I look, is x squared a perfect square? Yeah, the square root of x squared is x. The square root of 16 is 4. If I double that, right, if I multiply and double it, I get 8x. This is a perfect square trinomial, so this would factor as my first term, my last term. Now, since this sign is negative, it'd be minus 4 all squared. You could also do it, what numbers multiply to give you 16 and add up to negative 8. That would be x minus 4, x minus 4. This one here, the square root of 16x squared is 4x. The square root of 25 is 5. If I multiply these together, I get 20x. And if I double it, do I get that middle term? Yes. Okay, so what happens here is I know this is going to factor out to 4x. Since this sign is negative or minus, I'm going to go minus 5 all squared. Now the next one, as soon as I see two terms, the first thing I must do is look for perfect squares. Can I take the square root of 4x squared? Square root of 4 is 2. Square root of x squared is x. The square root of 49 is 7. The square root of y squared is y. These are two perfect squares linked by subtraction. So 2x plus 7y times 2x minus 7y. Anytime you get a problem that looks ugly like this, it's probably a perfect square trinomial, right? Therefore, we're going to take the square roots of these. That's going to give you 2w. It's going to give you 7z. I know 2 times 7 is 14. If I w, that's 28, wz. So I know this is. So all we're going to do is say 2w. I'm going to take that sign minus 7z all squared. Number 9, two terms linked by subtraction. Can I take the square roots? The square root of 49x squared is 7x. The square root of 16 is 4. So right away, two perfect squares linked by subtraction. 7x minus 4 times 7x plus 4. And the last one here, take the square root of both. 3x. This is 2. 6x times 2 is 12x, so it's a perfect square trinomial. So 3x plus 2 all squared. Again, for these, you can use any of the other factoring methods that we've used. It's just a little more complicated to make it happen. Okay, so go ahead, try the quiz, and let me know if you have any questions.